Yes, dear students, good morning. Today I will take the topic inelastic collision. I told you inelastic collision uh, causes loss of kinetic energy. The collision between two or more bodies in which momentum remains conserved but kinetic energy lost. And I told also if two bodies collide and after collision they get embedded into each other as shown in figure and move with a common velocity, then it is called perfectly inelastic collision. So here I will discuss perfectly inelastic collision. So let in figure two bodies of masses m1 and m2 moving with velocities of magnitudes u1 and u2 respectively. Make perfectly inelastic collision. Let after collision the magnitude of common velocity v. Here I am taking only perfectly inelastic collision. In perfectly inelastic collision, or this is also called as plastic collision. Bodies after collision get embedded into each other and move with common velocity. Here momentum is always conserved, I told you, because no external force acts between the two. They collide, so they apply internal forces. Now applying law of momentum. Here we can write applying law of conservation of momentum. I hope you have got it. Product of mass and velocity. Yesterday I was teaching students and they were not able to tell while they are studying the same chapter what is momentum. Please keep on revising. So we get final momentum m1 plus m2 into v equal to initial momentum m1 u1 plus m2 u2. Now you might be thinking, what is our aim here? Here we have to prove that kinetic energy is lost in inelastic collision. Here we have to prove that kinetic energy lost. So now let us find the velocity after collision, that v equal to m1 u1 plus m2 u2 upon. Dear learners, this topic is very important in every exam, in every walk of physics. Wherever you go, collision will always be coming before you every time. Up to final MSc classes, collisions remain in the picture. So learn the basic and keep in mind the basic facts. Like you remember the tables of up to 20 in your brain. So this is the velocity after collision. Now we have to prove कि kinetic lost. Common velocity भैया after collision. So initial kinetic यानी kinetic energy of the bodies before collision. Before collision equal to half. Let I write it K initial. Kinetic K for kinetic energy. Half m1 u1 square plus half m2 u2 square. Now finally velocity has become v. So final kinetic energy क्या हो गई? Final kinetic energy या kinetic energy after collision. Kinetic energy after collision. I write that Kf equal to half m1 plus m2 into v square. But you have got v as half m1 plus m2 into m1 u1 plus m2 u2 upon m1 plus m2. What is this? This is the value of this v. Just we have determined it. Nami? So how to get it solved? Square. So it will come out half m1 u1 plus m2 u2 whole square upon m1 plus m2. This square of this get cancelled by this. So this is final kinetic energy. That is kinetic energy after collision. Now you want to prove there is loss of kinetic energy. So loss of kinetic energy in this collision. Ki minus Kf. What is Ki? Half m1 u1 square plus half m2 u2 square. Or the total kinetic energy before kinetic half m1 u1 square plus half m2 u2 square. And final you have determined this minus half m1 u1 plus m2 u2 whole square upon m1 plus m2. Actually this topic is not treated this way, the way I am telling. They simply take one body at rest and other collide with. So this loss now here to be calculated. So Ki minus Kf. This half is common. Half common m1 u1 square plus m2 u2 square minus m1 u1 plus m2 u2 whole square upon m1 plus m2. Now you have to solve it. Easily we can do this. We can take LCM m1 plus m2. Now this multiply both will give you here m1 square u1 square plus m1 m2 u1 square plus m1 m2 u2 square plus m2 square u2 square minus, open the whole square only, m1 square u1 square minus m2 square u2 square, or minus 2 m1 m2 and u1 u2. So this come out to be the k I minus kf is equal to, this cancelled here, this is cancelled here, m1 m2 m1 m2 m1 m2 common, so half m1 m2 upon m1 plus m2 into u1 square plus u2 square minus 2u1 u2 2u1 u2 equal to half m1 m2 upon m1 plus m2, and it is u1 minus u2. What are u1 and u2? These are the initial, these are the velocities of two bodies before collision. Whether u1 greater than u2 or u2 greater than u1, square is positive. Square of negative number also positive. So here, this is ki minus kf. Since, if u1 is not equal to u2, अगर ये बराबर है फिर तो जीरो, तो लॉस होगा ही नहीं. अगर u1 u2 जीरो बराबर हैं तो they will not collide at all, and if they don't collide there is no loss of energy. But if u1 or u2 are not equal, here in figure I have shown moving in same direction, they may come out, they may collide while moving in opposite direction also. But then u1 minus u2 whole square is positive greater than 0. Any number greater than 0 means positive. So ki minus kf greater than 0, because this is positive, and hence ki minus kf, so ki greater than kf. So loss is must in head-on inelastic collision. This is also called here perfectly inelastic collision. The loss of energy there. Some people don't treat this way. They ask question other way also. But remember, dear student, this expression, loss of kinetic energy, half m1 m2 upon m1 plus m2 u1 minus u2 whole square. This type of expression you will be getting at many places. We will learn rotation motion. Their rotation energy will be there. So the same expression will be dealt there in one question in NCERT. In class 12 you will learn capacitors. Capacitors are devices to hold electric charge, and when we charge a capacitor, energy is stored in that. So when we connect two capacitors which are unequally charged, हैविंग डिफरेंट पोटेंशियल। मैं भाई थोड़ा ऊपर लिखा गया है, मैं कह रहा हूँ उसको याद रखा, डेल्टा के हाफ m1 m2 अपॉन m1 प्लस m2 है भाई, ब्रैकेट u1 माइनस u2 होल स्क्वायर। It is the case of head-on, perfectly head-on inelastic collision. Any collision in one dimension which is perfectly inelastic. You will get such type of equation many times if you are preparing for good exams, and I should say that you must try your best. And life becomes simple. You can serve people if you know something, and if you don't know something, you can't. How can you serve the people? Here my aim is totally to give the knowledge to students who are not able to reach good classes, good coaching centers. Actually, I remember Eklavya in Mahabharata. After hard working, done by him hard work, he learnt without his teacher, imagining that my teacher is with me. Keep on applying your wisdom, keep on thinking, keep on understanding the world, the happening in the world, what is happening around you. You must consider that. Now what I am telling, in perfectly inelastic collision, people ask like this: a mass m2 at rest, u2 equal to 0, and mass m1 collides coming with velocity u here, and they get embedded. After collision, they move with common speed. To prove that this speed v is less than u, prove that speed v after collision is less than u. So again, momentum is conserved here. So m1 plus m2 into v is equal to m1. m1 is only, ठीक है भाई? तो v is equal to m1 upon m1 plus m2 into u. So naturally m1 plus m2 more than m1, since m1 plus m2 greater than m1. So m1 upon m1 plus m2 less than 1, and hence v less than 1. V less than u. This is one thing. Now again, compare the ratio of kinetic energy after collision and before collision. We have find the ratio of kinetic energy after collision and before collision. So initial kinetic energy here Ki, before collision only half m1 u1 square. It is at rest u square. I am taking u only. Then K final after collision, that will be half m1 plus m2 into v square. This velocity after collision kinetic energy, half m1 plus m2. So, but v is this, or equal to half m1 plus m2 v square is equal into m1 upon m2, m1 plus m2 square into u square. It is left here half, this cancel, m1 upon m1 plus m2 into u square. This is the kinetic energy after collision. वैसे तो आप डायरेक्ट मेथड से ठीक है भाई। तो अब नाउ के एफ अपॉन के आई, रेशियो ऑफ काइनेटिक एनर्जी आफ्टर कोलिजन टू इनिशियल काइनेटिक एनर्जी, के एफ अपॉन के आई। के एफ इज हियर हाफ m1 u square upon m1 plus m2 upon initial energy only half m1 u square. Here it is m1 square, sorry, m1 square. तो u square, तो you this half cancel, square cancel m1, so it is left only m1 upon m2. They can give any question, then we have to follow the basic rule. In head-on elastic collision, the momentum and kinetic both conserved, but in elastic collision only momentum is conserved. So please, I have done this for you. Now I will solve many problems in coming videos. Please keep on revising.